In this video, we'll cover the functions to perform on equilibrium constants to make them fit slightly different reactions. Let's start with a pretty simple reaction. Thing A yielding thing B with an equilibrium constant that we'll label as number 1. If we flip this reaction for, let's say, a question like a Hess's law question, I need to figure out what my new K would be. We can do this by postulating what the old one looks like. If we write out the equilibrium expression, we'll get B over A. If we write out what the new equilibrium expression would be, it would be A over B. We notice that these are literally just reciprocals of each other. So we can shorten the process by saying K new is just equal to 1 divided by the first K. And that's how you handle the K if you flip the reaction. Now let's consider what happens if you double the reaction. Let's say we're starting with thing A and thing B again, with their traditional K number 1, and we want to know what happens when we double it. In this case, I still have my K1 expression equal to the concentration of B over the concentration of A at equilibrium, but my new K would be a little different. Now that I have coefficients, I'd have to use them as my powers. And now that I look at this, I realize the only difference between K number 1 and K new is that everything inside of K new is squared. This means that my K new is really just K1 squared. You can use this pattern of changing the coefficient into a power for any number that you multiply your chemicals by in your balanced chemical equation. If you multiply the entire equation by 3, you would have to cube your equilibrium constant. If you multiply all the coefficients by 1/2, you would have to square root your equilibrium constant. It's a pretty cool pattern. Now let's consider what happens when you need to add up equations, like you would in a Hess's law problem in thermo. Let's start with A yielding B again, with our really fun K number 1. And let's say we want to add it to a reaction where thing B is going to yield thing C, with a constant labeled as number 2. If I want to know what the equilibrium constant is for these two reactions added up together, I would realize that my B's are going to cancel out. My final answer is going to be thing A yielding thing C. So what I want to do now is come up with a shortcut for figuring out K new. We know that K number 1's expression is still going to be B over A. But now we can write down K number 2, which is thing C over thing B. And our new desired K new as thing C over thing A. Now I'm seeing with my eyeballs that the main difference between these guys is that K number 2 has C on the top, which is what I desire, and K number 1 has A on the bottom, which I desire. If I multiply the expressions for K1 and K2, my thing B's will cancel out, which means that my K new can be calculated by multiplying your first K and your second K. Each one of these tricks individually can be helpful for equilibrium problems, but most of the time, the questions are going to involve you doing a combination of all 3. Make sure that you do plenty of these examples so that you can see all of the tricks.